So I found a video to make learning about the rock cycle a little more exciting than me just talking and seeing some slides. So we'll watch this video pretty much in its entirety, and then I will pause it in a couple spots so we can add a couple more notes.
I bet you thought rocks are just rocks, right? Nope. There are three major types of rocks: sedimentary, igneous, and metamorphic. But the coolest thing about rocks is that each one has the ability to change into the other kind.
How is that possible? Sedimentary, metamorphic, and igneous rocks change into each other in a process we call the rock cycle. No, not that kind of rock. This kind of rock. Yeah, that's more like it. The first type of rock we'll talk about is sedimentary. On the surface of the Earth, wind and water break down rock into tiny pieces. Those pieces might collect in a riverbed, on a floodplain, be swept into sand dunes, or collect on the ground.
That process that actually breaks up the rocks is called weathering. That can be done through mechanical weathering, where the rocks are physically broken up by things like water temperature changes. The roots of trees can do that if rocks are scraping together. That can also happen chemically. So if things like acid rain or acid precipitation comes into contact with the rocks, that can also, that exposure can break down the pieces into sediments. Now, erosion is the process that he's about to explain here, where those little particles, those sediments, are actually moved from one place to another and deposited into a new place. So they don't talk about the specifics of those very well, but those are important processes.
Over time, layers of these rock fragments build up and start to weigh down on one another. Eventually, they get fused together to form sedimentary rocks. The cool thing is that if you look closely, you can still see pieces of the original rocks or sediment that were bound together.
Let's do a demo. For our rocks, we're going to use jelly beans. Each flavor of jelly bean represents a rock or mineral that has been broken down by wind and water through a process called erosion.
And weathering.
We put our jelly beans in this bowl and add some honey and cornstarch. They're the bonding agents to hold our pieces together, kind of like glue for rocks. A little time and pressure has turned our jelly bean pieces of sediment into a brand new rock.
So what happens if you apply both heat and pressure?
All right, I'm going to pause it there really quickly. Under sedimentary, that really should say weathering and erosion, and that's actually not completely accurate either, because weathering and erosion are actually processes that are going to make sediments. Those particles of rocks that then are deposited somewhere, and then it's that cementation and compaction. As water moves through those sediments, minerals are going to stick to the pieces and basically glue them together to make the sedimentary rock. So there are two processes, or more than two, but weathering and erosion along with deposition are going to make those sediments, and then it's the cementation and compaction that actually makes the sedimentary rock. So now moving on.
It becomes a metamorphic rock. Metamorphic rock may form by friction of the Earth's shifting crust, pressure deep within the Earth, or even radioactive decay. The heat and pressure cause the rock structure to change, so it takes on a new form.
A quick little note here, heat and pressure are super important, and you'll see how that works with the jelly beans. Just notice how there's heat applied, but not so much heat that the rock completely melts. It just does change composition a bit.
Even though it's changed, you can often still see structures of its original components.
Let's take our sedimentary jelly bean rock and turn it into a metamorphic one with heat and pressure. To add pressure, we'll put this heavy pot on top. For heat, we'll stick it in the oven for about 30 minutes. After it's cooled, you can see how our jelly bean rock has formed a more solid unit. However, you can still see the individual pieces of candy, but the structure has fundamentally changed.
The third type of rock in the rock cycle is igneous. When rocks get superheated deep within the earth, they melt and form a liquid called magma. If magma rises to the surface or moves up
I cut him off there a little bit, but because igneous rock forms from magma or melted rock, it really is sort of the first type of rock that forms. And you'll notice how there's some magma coming to the surface up here, and then some magma that's getting trapped in a chamber underneath the earth. When the magma rises to the surface and cools into new rock, that igneous rock is called extrusive. It cools much faster and it makes rock that has very, very, very small crystals that you can't even see. The first rock that they show you an example of is a great example of that because it almost looks like glass. Rock that forms under the earth or cools under the earth like that is called intrusive igneous rock, and it cools much more slowly, which allows the minerals in the rock to form much larger crystals. So if you have like a granite countertop at home, it might look really speckled, and you're seeing those individual crystals that formed from it cooling relatively slowly.
Earth's crust, it begins to cool. Igneous rocks have a uniform structure throughout, but will have different properties depending on whether they cooled on the Earth's surface or within the crust.
To turn our jelly bean metamorphic rock into an igneous rock, we're going to melt it in this pot of boiling water. When our rock has cooled, you can see how all the different pieces combine to make an igneous rock with uniform structure throughout. Pretty cool, huh?
But this is only part of the story.
I'm going to pause it there really quickly. Notice how by igneous it does write magma. So the igneous rock forms from the magma, but just remember that magma does have to cool and crystallize. So yes, it melts into magma, but then cooling and crystallization is what actually forms that solid rock.
We showed you one path through the rock cycle, but really any rock can go from one type to another. For example, igneous rocks can turn into either metamorphic or sedimentary. And metamorphic rocks don't have to become igneous rocks. They can be broken down again and become sedimentary. Or the sedimentary rocks can get pushed deep within the earth to form igneous. See, all of the rock types are connected, making a cycle that never ends. The end.
All right, that is it. So make sure to do the reading for this section as well.